Hello.
Hello.
Hi, Christiani. How are you?
Good. How are you?
Yeah, I'm good. Okay. So this is a dot clearing session. So please share your questions. Okay.
Okay.
Yeah.
Um, Here, let me look at my homework then. See if there's any.
And how your preparation going on? Everything is
Yeah,
going on.
I've just been taking some like practice tests that my teacher gave us. I think like the practice is helpful. But
That's good.
yeah.
You can also take the practice test from the college board website. They have
Mhm.
the test for particular chapters.
Okay.
Okay.
hmm could we go over like momentum and energy?
You want to go what theory of that?
More like yeah, I guess theoretically, because I think I'm okay with like the math for momentum and everything. But sometimes I get confused over like I
I
guess
got
like the
I
stuff where
got
it's like a hollow sphere or like like the rotational momentum.
yeah. 1 minute. So momentum has many topics, conservation of momentum, say you like
Yeah.
go to the topic. So yeah, linear momentum, impulse, conservation of momentum, elastic and inelastic collisions. So where should we start from?
Could we start with elastic and inelastic?
Okay, perfect. So basically, I think you know about collisions, right? Okay.
Yeah.
So in collisions, when there is no external force applied on the system, then then what happens? Do you know that? When there is no when,
Um
yeah, yes. Carry on.
yeah, I don't know.
Okay, no worries. Okay. Hmm. Okay. So basically, you will first choose a system. Okay. I think you know what collision, you know what momentum, right? What is momentum? You
Right.
know that? Is
It's
that
like
right?
mass times velocity of an
Yeah.
object.
Yeah, that's mass times velocity vector. Remember, it's velocity vector, not speed. Okay, it's a
hmm
velocity vector. That's why the direction of the momentum vector will be the direction of the velocity vector. Okay, but the magnitude of momentum will not be the magnitude of velocity vector, right? Because it is mass multiplied by velocity. Okay. Now, let's go to selecting a system. Okay. And what are internal forces and what are external forces? Do you know? What do you mean by internal and what do you mean by external forces?
Internal forces are like the forces that are part of the system. And then
Yes.
external forces is like friction or anything that's like removing energy from the system.
Wait, it's not necessary friction. Friction can also
Oh.
be an internal force. Okay. Okay.
Oh.
Okay. So actually, internal force means like, see, whatever force is applied by one part of the system to the another part of the system. Okay, like if there are two objects like this, okay, they are going to collide. Okay, if you select now when they collide,
Oh, I
okay.
can't see your screen.
Oh, I'm sorry, let me
No,
share.
you're okay.
Okay, so basically these are two bodies that are
hmm
coming to collide each other. Okay, now when they collide, so during the collision by the Newton's third law, this body 1 and this is body 2. So body 1 will apply force on body 2 in this direction. Is that right? And
hmm
body 2 will apply force on body 1 in this direction. Is that right? Both of them will apply force of equal magnitude on each other. Is that right? Is that right?
hmm
So this is by Newton's third law. But here, if you consider both of this both of these objects as one system. Okay, system, what you want to choose the system, that depends upon you. Okay, you can choose either only body 1 as the system or only body 2 as the system or body 1 and body 2 combined as a system. Okay, that depends upon you. Now if we choose both of the bodies as a system, okay, Then the force applied by one part of the system to the another part of the system. Now body 1 and body 2 both are the parts of the same system. Okay. So whatever force body 1 is applying on body 2 and whatever force body 2 is applying on body 1, they are becoming now internal forces. Are you getting that? Why they are internal forces?
Hmm.
Hmm?
Yeah.
Because it is one part of the system that is applying on the other part of the system. Okay. So that depends upon what you have chosen a system. Now, if I just consider body 2 as the system, okay, if my body 2 is only the system, okay, this is the system, okay. Now here the force applied on body 2 was F2, F12, is that right? And that was applied by body 1. Now, is this F12 a external force or internal force in this case?
External.
Yes, because this F12 is applied by a body, another body, that is body 1, and you have not considered that as the system, right? This is
Right.
not the part of your system. So you got to know about the concept of internal and external forces. Is that right? Okay. Now, when you got to know about internal, now you need to know that when you select a system, okay, and in that system there is no external force applied. If summation of external forces is 0, okay, then in this situation the momentum of the system is conserved. That is, initial momentum of the system is equals to final momentum of system. Okay. Okay. Now, basically, in all the collision, most of the collision problems, there will be a car. Okay, there will be two cars like this.
Hmm.
They will be colliding, or there could be two billiard balls. They would be colliding. Okay. So in both of the cases, what we do is that we select these two bodies as one system. Is that right? Why do we do that? Because when we select these two bodies as part of one system, then the force applied by the one on another, okay, these two forces, okay, that are acting on each other, right, during the collision, okay, that they becomes the internal forces, and we could apply the law of conservation of momentum. Yeah. Are you saying something?
No.
Okay. So we can apply. So what is the initial momentum of the system? So this is ball 1, this is ball 2. So P1I plus P2I is equals to P1F plus P2F. That means initial momentum of ball 1 plus initial momentum of ball 2 is equals to final momentum of ball 2. Uh, Final momentum of ball 1 plus final momentum of ball 2. Are you getting that? So this is the way we try to write, we make a system such that the external forces on that system is 0, and we apply momentum conservation in that manner. Regarding
Yeah.
why I have done P1 and P2, because the system consists of these two masses. Is that right? So initial momentum of the system is the initial momentum of all the parts of the system. Is that clear? Please tell
Yeah.
me.
Yeah.
Okay. Now, after this, what topic? So we have done the momentum conservation. Now, after that,
Could we talk about like conservation of momentum with like rotational motion and like different like hollow spheres or like moment of inertia and stuff?
oh, you are saying about angular momentum conservation, I think. Is that right?
Yeah. Mm-hmm.
Is that, yeah. This was what we are talking about, linear
Linear.
momentum, right? Yeah. So angular momentum conservation works when, now see here, this is linear and that is angular, right? So instead of force, you will have net torque. Are you getting that? So
Yeah.
when net external torque on the system is 0 on the selected system, then the initial angular momentum of the system is equals to final angular momentum of the system. Now you will just find out the situations where the net external torque on the system is 0. Is that okay? So you will just select the systems. You will just choose the systems where net external torque is 0. Like if there is anything, okay, okay. If there is a disk that is rotating like this, okay, is that making sense? Now, if
Yeah.
you suddenly drop a disk or drop a mass from here, and that gets glued up here. Okay, so because this got glued up here, does this uh, like this one does not provide any external torque on this system. Okay, so you can say that the angular momentum of this system will be conserved. So yeah, when the net external torque on the system is zero, that time the angular momentum of the system is conserved. Do you want me to go through some example questions of this?
Yeah.
Okay. For linear or angular?
Angular.
Okay. Okay. Second condition of equilibrium forces. Dynamics, angular momentum and conservation. Okay, I got it. Okay, why does the earth keep on spinning? What does it state? Okay. In faster and simpler process. Okay, do you know the answers for this kind of questions? Like, how does an ice skater manages to spin faster and faster simply by pulling her arms in?
Oh, so they would have like a lower moment of inertia. So then acceleration would go up and then like in turn velocity.
Wait. When she lowers her moment of inertia, if he pulls her arms inside, right, then her moment of inertia decreases. Is that right? Because the
Right.
distribution of mass is more nearer to the axis of rotation. Is that right? So,
Right.
what happens because of that?
Then velocity goes up.
Angular velocity. Is that right? Mention the
Yeah.
angular velocity, because velocity also means linear velocity, right? Okay.
Yeah.
So angular velocity goes up. So why is the angular velocity going up? When the moment of inertia decreases, so why is the angular velocity increasing?
Um, because I don't know. Yeah.
Okay, so actually here in this case, is there any external torque acting on this system when she was
No.
rotating? No, right? So you can apply law of conservation of angular momentum, right? That means initial angular momentum is equals to final angular momentum. Is that right? That
Yeah.
means this I1 omega 1 is equals to I2 omega t, right? So if the I decreases, then omega has to increase to make the angular momentum constant in value. Is that right?
Yeah.
Are you getting that? So you got
Yeah.
your answer? Okay. Okay. Now some more questions on this is this one. I think this is an easy one. I think you can do this, right? Have you seen
Yeah.
the question 10.11?
Yeah. I see it.
Okay. So do we jump to another question? I think these are easy ones. Or just check and let me know.
Mm-hmm. Yeah, I know how to do this. Yeah.
Now, according same, like in the angular momentum and torque, this is like rotational analogies of all the linear things. Like force is replaced by torque, linear momentum is replaced by angular momentum. Like, do you remember what was the relationship between the net force and the linear momentum and the time taken?
Um, Angular momentum is torque times change in time.
Yes, that's correct. Angular momentum is, yeah, it's not angular momentum. It's the change in angular momentum.
Oh,
Remember,
impulse.
yeah, 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 that's correct. You can also say that is impulse, or you can also say that is change in angular momentum, right?
Yeah.
Getting that. So remember, don't do it's not angular momentum, it's change in angular momentum. So change similarly, you will see that change in linear momentum is net force multiplied by the time over which it has been acted. Is that right? Is that right?
Yeah.
So yeah, all these things are related. The force has been replaced by the torque, linear momentum by angular momentum, and time by this. Okay, this one. This is also a similar kind of easy question. Just check this.
Yeah, I know how to do this.
You know it? Okay, perfect. Okay, so this one, change in angular momentum is equals to net torque multiplied by time taken, right? You can calculate
Yeah.
the net torque by the force multiplied by lever arm. Okay, so I think you are able to do this question. So where are you struggling in angular momentum? Can you please tell me?
It's more about like the different, like when it's like, oh, there's like a sphere and then there's a cylinder and like a hollow ring going down like a ramp or
Oh,
something. Like which one gets there first, which one has more momentum, that kind of
okay,
thing.
okay, okay. I'm going there. Hmm. Okay, so it's about like this, right? Like there is an incline and there is a sphere that is going down, right?
Yeah.
Is that right? There is also a cylinder that is going down, right? So yeah, what you are trying to calculate in this case?
Like final velocity or final momentum.
Okay, so you have to use energy conservations here. The potential energy has been converted into kinetic energy. This kind of concepts. Are you getting that?
Yeah.
Hmm? So finally, what is the initial total energy of the system? If we
Um,
consider this sphere, so is that only potential energy, that is mgh?
yeah.
Is that right? And that is being converted. So when it is just about to hit here, so what is the final energy of the system?
It's all kinetic energy.
Yes. So kinetic energy, is that only translational kinetic energy? Is that 1 by 2 mv square?
So you would have translational and rotational.
Yes. So kinetic, translational plus rotational. So this is the translational one, and rotational one will be a 1 by 2 times of I times of omega square. Is that right?
Yeah. Yeah.
So you will just equate both this 1 by 2 mv square plus 1 by 2 times of I times of omega square. Now omega is square, right? Now this is like a pure rolling case, right? So in pure rolling, you know that V equals to omega, right? For pure rolling. Do you know this thing?
Yeah.
Hmm? That means there is no slipping. Okay. And V equals to omega. So omega can be replaced by V equals to omega. So omega equals to V by R, right? So V by R whole square. Okay. Okay. And yeah, now 1 by 2, sorry, 1 by 2 mv square plus. Now what is the I? So I is 1 by 2. So I is some constant k multiplied by mr square. You know this thing? You know this thing?
Yeah.
That depends upon the geometry of the surface, the value of k. Is that right? What is the
Mhm.
value of k for this sphere? You have to check that. Okay, that may be given in your formula set, right?
Yeah.
So from this, you will get this equation mgh is equals to 1 by 2 mv square plus r square got cancelled here. So plus 1 by 2 times of k times of mv square, right? So, and mass can also be cancelled from both of these sides. So gh is equals to, is that right? If you divide both of these sides by mass, so the equation will change into 1 by 2 times of v square 1 plus k, right?
Mhm.
Now what you will do, you can find out the velocity v. Okay, if you find out v, you can get the omega. Is that right? And
Yeah.
if you, whatever you want to do, you can do the other calculations from here. If you want to find the final momentum of this angular momentum of the system, you can say I times of omega, right? You will get the final omega, because omega is equals to v equals to omega r. So omega equals to v by r. You will get the v from here, and you can do v by r. You will get that. You will put here. Are you getting that? Hmm?
Yeah.
So this is basically a kinetic energy conversion problem. This one. This is not angular momentum problem. Okay. Okay.
Mm-hmm.
Okay. Now please ask what else.
Let me check. Could we go over like cycle frequency and like rotations per minute and like what all of that means? Because sometimes I get them confused.
Why not? Yes. Okay. Okay. Cycles. Okay. So that is about in SHM, circular motion, right?
Yeah.
Is that right? Okay. So what is one cycle? Like, okay. Let me show
Yeah.
you. Like, and what is one time period? Okay. So time period is basically, like if this in the horizontal axis, if there is time. Okay. And if you select two identical points, any two identical points. So if I select this point, then what is the identical point to this? Is
Like the one
that
on the
here?
other side. Yeah.
Is that here? Yeah. Okay. So this one is here, right? So these two are identical points. So the distance between these two, the distance between these two, and if in the horizontal side, if this is the time, okay, then this is called time period. This will be time period. If
Okay.
in the horizontal direction, it is not time on the horizontal axis. If in the horizontal axis, there is your uh, distance traveled by the wave, okay, distance traveled by the wave, okay, x in meters, okay, then this will be your wavelength, lambda. Are you getting that? Hmm?
Yeah.
And if this is the maximum height from the mean position, so this is what, this is called
Ampli
the amplitude, right?
Mhm.
Okay. Now, when you got the time period, if they are in the horizontal axis, there was time, okay, then 1 by time period is called frequency, okay,
Yeah.
and the unit of frequency is hertz in SI units, okay. Okay, and yeah, and if you have in the horizontal axis x meters, that is the distance traveled by the wave, then this one complete cycle, the distance between two identical points is called lambda. Okay, so lambda could also be from here because this point and this point are also identical. So this could also be lambda. Is that right? Is that right?
Mm. Yeah.
Is that making sense? Okay. Now you got to know about frequency. And actually, what is frequency actually in theoretical? So frequency is number of cycles per second. Okay. Time period is, what is time period? Time period is the time taken for one complete oscillation. Okay, one complete oscillation. Okay. Now, what is the speed of any wave? Okay, speed of any wave. Okay, speed of any wave is given by frequency multiplied by wavelength of the wave. Okay, this is a formula. Okay, is that making sense? Is that making sense?
Yeah.
Okay. But this one, frequency of a wave, is this related to your topic? Okay, okay. Uh, can you please tell me what topics, what should I discuss more on this, like amplitude, time period, frequency, what else I
Yeah.
left?
Rotations per minute and like revolutions per minute. Because is that like, because I always get confused over like if that's frequency or as a
Okay.
time. Sometimes you have to like convert, like you have to like, there's some formula where you like divide by 2 pi, multiply by
Oh,
like,
yeah. Yes, that's correct. Okay. So V equals to omega R, you know this formula? Okay. So, yeah. Okay. When there is a circular motion, Then the omega is the angular velocity. Okay. Omega is the angular velocity. V is the linear velocity. Okay. And
Okay.
R is the radius
Right.
of the circular path. Okay. Now, angular velocity is actually equals to angular distance traveled by the time taken. Okay. Okay. Now, when the angular displacement is 2 pi, okay, okay, and the time taken is capital T, right? So you know that angular velocity is the angular displacement by the time taken, right? And
Right.
and T is the time period, right? So in time period, one time period means one cycle, is that right? So one cycle, does that also means one complete revolution? Is that right?
Yes.
Is that right? So angular velocity is angular displacement by the time taken, right? So in one time period, what is the angular displacement? Is that 2 pi?
Oh, okay. Yeah.
Is that right? So we can also write that angular velocity is 2 pi by time period. Are you getting that?
Yeah.
Okay. This is one relationship. And time period is frequency, 1 by frequency. Is that right? No. I told you here, time period is 1 by time period is frequency. Is that right?
Right.
1 by time period. So this can also be written as 2 pi time multiplied by frequency, angular velocity. Is that making sense?
Yes.
These equations will help you while you are doing Kepler's law questions. You remember that there is one sun, there is another planet that is rotating around, right? Yeah, in gravitational, right? Okay. Okay, what else we left? Can you please tell me here in this topic?
Okay, Rahul, I think she's done.
Oh,
But
that's my mom. Sorry.
yeah, sorry. Yeah. So can you ask her like randomly from each chapter? You have any question from college board where you can just test her on one questions like that? So if she
Yeah,
to do,
sure. Yes, sure. Yeah, I can do that.
you have college board questions.
Uh, College board questions. Actually, ma'am, she has the login, so she can directly go there. I have past previous year questions from the college board that are on my drive.
Okay. Maybe something what
But
you think,
correct.
you know,
Yeah.
just whatever she asks question, even in that, if you can ask her some question, one or two, and if she's able to solve it, then I think she should be good at it.
Okay.
You're really a good teacher, you're dedicated. If some friends ask for physics teacher, I will share your number.
Yeah. Thank you, ma'am.
Yeah.
Okay. Yeah. So yeah. Where should we start from? Kinematics, dynamics, rotational motion, or SHM? What do you think?
We can do rotational motion because that's mostly what we did today.
Okay.
Yeah.
So for rotational motion, I have some good questions. They are this one. Okay. So this is that kinetic energy relationship. Okay. Try this.
Yes.
Okay. So what do you think? How would you solve this kind of questions?
So I would first set up like I would do like conservation of momentum for this one.
Conservation of momentum, angular momentum,
Oh, sorry, conservation of energy. Yeah.
conservation of energy. Okay. Okay.
So I did like I did mgh
Okay. Yes.
equals, yeah, so I did mgh equals
Is
And
the
then I
H
like,
is the D?
oh yeah, D.
Okay.
And then I did like, what did I, yeah. And then I did 1/2 I V squared.
1/1/2 I V square or 1/2
V,
I omega
velocity. Yeah.
omega square or V square?
Oh yeah, omega.
Yes. See, that got confused here, like
Yeah.
yeah, this is you are using angular term, right? So everything will be angular terms, right?
Yeah.
Okay. Now what after that? I think you got the answer. Now you can just do you will need to do the convergence.
Yeah, and then I just started moving things across.
Yeah. You will write I in terms of m r square, right? 1/2 m r square.
Yes.
Omega, you will convert this into in terms of V and radius. Is that right?
Right.
Is that and you will write the equation. Okay. I think you are done with this. That's
Okay.
go to some other question. This one. That's look scary.
Yeah, that's a lot of words.
But it is not a scary question. It just looks scary,. But it's very simple. They have just
Yeah.
make a big diagram to scare you. Okay, so were you able to find out that there is energy conversion taking place?
Yeah, so I set up a similar thing that I did for the last one. So I did potential energy equals 1/2 moment of inertia omega squared.
Yes, of course. Because there is only rotational kinetic energy. Is that right?
Yeah.
Is that yeah? So yeah, you have I and one I is 1/12, 1/12 times of m times of L square.
Hmm.
Would you replace L with something?
I would replace L by distance,
Distance?
right? Or
Well,
diameter, sorry.
yeah, diameter. Perfect. So you are done with this. So
And then
that
so
is
would
what
the answer be the second one or the first one with like the square root of 24?
okay. So 1/12 times of I times of omega square, right?
Yeah.
This is equals to PER. Is that right?
Mm-hmm.
Hmm? Hmm? Now I is 1/2 times of I is 1/12 times of m times of d square. That is omega square is equals to PER. Is that right? Okay.
Yes.
So now you will have omega square is equals to 24 PER divided by m times of d square, right?
Yes.
So
Yep.
yeah,
So
we have option number E. That's correct.
yeah.
Hmm. Okay, these are easy questions for you. uh, question number can okay this one problem 2.
Mm-hmm. Yeah, I'm not sure how to do this one.
Okay, so what is happening in this scenario? Like, can you please tell me the scenario? What is happening here?
So there's three small spheres connected to like two rods of like no mass. And
Is
then
there
they're rotating like
two
this
rods?
around the axis of like the rod
Okay,
with
so
equal
are you
force.
changing the axis? Are we
No,
changing the axis? Okay,
no.
okay. So physics lab CSN. Okay, set up. Okay, set the system up so it rotates around axis A, B, and C as shown. Oh, we are changing the axis.
Oh, we are.
Your
Oh,
student in a physics lab can set up the system up so that it rotates around axis A, B, and C as shown. Is that right?
mm,
Is that right? So we will select three different axes, right? In all the three cases, the same force will be applied exactly in the direction and location shown. So the force F will always be acting at point C. Is that right? And that will always be perpendicular to that lever arm B to C. Is that right? Hmm?
mhm.
Yeah, but we will select three different cases. In first case, our axis of rotation will be A, in second case B, and in the third case it will be C. Is that right? Hmm?
Yeah.
Is that right? So if you select three different cases, right? So now what they are asking is that, okay, assume that in all three cases, counterclockwise positive direction on each axis. The system always start from rest. Okay. Lastly, assume that the force is the only F is the only force in the problem capable of applying torque on the system, and F will change directions over time so that it is always perpendicular to the rod. Are you getting this? Hmm?
Mhm.
Okay. Okay. Now I think you got some idea about this, right? So what do you think about angular velocity with respect to time when we are selecting axis A, axis B, and axis C?
I think it would be equal for, I mean, I think it would be greater for axis C because force is like closer to it.
Okay, let's see. So that will depend upon the torque that has been generated in the system. Is that right?
Mm-hmm.
Is that right? When you select this system C, is that right? If you select axis as the C, is that right? Then what is the torque that is being generated? We will not think. We will just go with the physics concepts. Is that right? So
Yeah.
just select the C as your hinge point, or that is as the axis. Then what is the torque generated by the force F? Is the
Um,
force F passing through the axis or the hinge point itself?
yeah.
So will that force generate any torque?
No.
No. So why you are saying
Well,
that? Hmm? Okay. So basically, we have to see, you know what? You have to read the problem, understand what it is given, right? If you're not understanding, read it again. And then visualize it that, yeah, what is actually happening there? And then break down the things into small parts. You cannot solve this complete in one step. There is not one step answer. You will break this into small parts. See what I have done. I have broken this, right? So I got to know that, yeah, there are three different axes. So I have said first I will select axis C. I have broken this. Now let's do the calculation for this. When there is axis at C, then the net torque is zero. Is that right? Is that right?
mm-hmm.
So
Yeah.
when net torque is zero, what does this mean? For angular velocities, net torque is zero, that means angular acceleration is zero. Is that right?
Yeah.
Is that right? Angular acceleration is zero. What does this mean for angular velocities? Does,
Um,
okay. If you are forgetting this, then I just give like I know that many students like they have issues with this torque. This is confusing, but
yeah.
no worries. When you get confused, just write the linear things of this. Torque can be written as net force. Is that right? The
Right.
equations are same. The equations are same. This will give you a hint of which equation you will use. See how it will give you a hint. When net torque is zero, then acceleration is zero. Is that right? Is
Right.
that right? Alpha can be replaced by A in linear, right? Now, when acceleration is zero, then what do you know about velocity? When
velocity is also like constant.
velocity is constant. Perfect. So what will be constant in the angular term?
Angular,
Omega, yeah,
angular velocity.
velocity. So omega I will equals to omega f. Is that right?
Mm-hmm.
Is that right? And what is
Yes.
omega I in this case?
0.
0. So omega f will be 0. Okay. So yeah,
Mm-hmm.
here angular velocity graph of the C will go like this. Is that right? It will coincide with the x-axis. Is that right?
Yes.
Okay. So this is for C. Now let's go for the B. Is that right? I think now you can do for B, right? Is that
Yeah.
right? So B, you will have some torque. Is that right? And for A, now what will be the difference between B and A graphs of angular velocities? So for B, you will have some torque. So when there is net torque, that means net force, then there is net acceleration, that means there is acceleration. And when there is acceleration, then angular velocity will change. Is that right? So which one has, so if angular velocity is changing, right? That means this is an accelerated motion. Is that right? So this is
Right.
the accelerated motion. So how will the graph of angular velocity versus time look like? Will that
Uh,
be a straight horizontal line, vertical line, or a slope or a straight line with constant slope?
would it be a straight line with constant slope?
Of course, because that is like the slope is slope of velocity time graph gives acceleration, and that is constant in this case. Is that right? So yeah,
Yes.
it will. And where will the graph start from?
The
Will that
origin.
start from here or origin? Yeah, because initial angular velocity is 0.
Right.
Is that right? So this is for omega b. And what about omega A? How will that graph look different from this? Or will that be same?
Would that slope be like small?
Okay, but how do you know that?
Oh wait, because if torque goes up, then yeah.
Okay, alpha is actually net torque by net I. Is that right?
Right. Right.
Is that right? Hmm?
Mm-hmm.
Now, when you choose this A as the axis, will the I also change or will that remain diff same? That will also
That'll.
change.
Oh,
Hello?
does it change? Does it stay the same? Yeah.
It will change because moment of inertia depends upon the axis you are choosing. Is that right? Initially, you were choosing the axis as B. Is that right?
Mm-hmm.
Now you are choosing axis as A. So that will depend upon the magnitudes of both. Is that right? So you cannot directly say that net force because here I is also changing, right?
Oh,
Is-
okay.
Yeah, this is complicated one. Okay, little bit tricky. Yeah.
Yeah.
Yeah, so you will find the new I now, right? What is the IA? You will find what is the IB. Is that right? I think you don't need to find IC. Is that right? You don't
Yeah.
need to find because torque is 0. Then you don't even need to find. You just say torque 0. So yeah, skip this. Just find IA and IB and then put, and the torque will also be different in each of the cases. So torque net by IA, torque net by IB. Is that right? In each of the
Mm-hmm.
cases, and then you will get an idea whose slope is higher, whose alpha is higher, and then you will draw a line like this, right? Will that go up or will that go down? Is that right? Is that making sense?
Yeah.
Hmm. Now for angular acceleration,
Um, so C again would have an angular acceleration of 0, so that would just be on the axis.
yes, and then for A and B, will that be a straight line with constant slope, horizontal line, or a vertical line, or a parabolic?
Um, would it just be a straight? Not a straight, like like a slope line, constant
Slope
slope.
line. Okay, a straight line with constant slope
Yeah.
for alpha versus time. Is that right? Now, please give me the reasoning behind your answer.
Well, I said it would be like I wouldn't be parabolic because there's no reason why it would like go down. Like there's no reason why it would become positive and then become like negative
Okay,
again.
wait a minute. I need to tell you about the graphs first. Okay, the graphs are like this. There are one graph is like this. The another graph is this is one equation. The another one is like this. Is that right? And the another one is like this or like this, whatever. Okay, so there are three kind of graphs, okay, which you will encounter in AP physics, right? One is parabolic, the another is a straight line with constant slope, the another one is this horizontal one. Okay, is that making sense? So what are the properties of this graphs? Do you know that? What is the property of this graph? What is the property of this graph?
I'm not sure.
Not sure? Okay, no worries. So when there is y and x, okay, and here y and x, y and x. Okay, so yeah, okay. Let's start from the parabolic curve. Okay, so when there is a parabolic curve, okay, then you know the slope is given by this, drawing a tangent line. Okay, so parabolic graph means that, okay, parabolic graph means that the slope is changing at a constant rate. Okay, slope is changing at a constant rate. So slope means what? dy by dx, okay, or
Right.
del y by del x. Whatever quantity you are getting by del y by del x, okay, this del y by del x is not constant. The slope is not constant. I'm not talking about slope is constant. The rate of change of slope, that means delta m by delta x is constant. Are you getting that?
Yeah.
The rate of change of slope, that means if this is a position versus time graph, okay, then the slope of this position versus time graph gives you velocity. Is that right? Is that right? So
Yes.
velocity is not constant. The rate of change of velocity, that means rate of change of slope. Now delta v by delta t is constant. Are you getting that? That means double derivative is constant in this case. Parabolic means that. Are you getting that? When there is a
Yeah.
straight line, then the slope is constant, right? Right?
Yeah.
Sorry, it's not this. Okay. So when there is a straight line with this constant slope, this one is a straight line with constant slope. Okay. Okay. So in this case, what is constant is that the slope is directly constant. So slope is what? So in this case, slope is delta alpha by delta t. Are you getting that?
Yeah.
So yeah. Uh, so this graphs have slope is constant. Slope is constant. That means delta y by delta x is constant. For the parabolic ones, the rate of change of slope is constant. Rate of change of slope. Rate of change of slope means delta m by delta t is constant. Okay, and for this one, whatever is the value in the y-axis, that y is constant. Is that making sense? Now you told me that in this case, is the angular acceleration constant, or is that varying? Is the angular acceleration constant or changing in this question?
I said it's constant.
Angular acceleration is constant. So when angular acceleration is constant, then with respect to time, you told that, why is this happening? Oh, I need to move this here. Okay. Okay. When you told that graph will look like this. So according to this equation, according to this graph, the alpha is increasing with respect to time. But we have find out that alpha is constant with respect to time. So why you told me this graph? The graph should look like this, I think. Is not that correct?
Yeah. Mm-hmm.
So this
Yeah.
is wrong. You got it? Because the
Yeah.
variable alpha is constant, right? It is not increasing at a constant rate with respect to time. Yeah, if that was a angular velocity, then you can say that the graph would look like this, because angular velocity was increasing at a constant rate with respect to time, right? And delta omega by delta t is alpha, right? That's slope, and slope is constant. Are you getting that?
Yeah.
Angular position. Now, what about angular position? So angular position will be what kind of graph? Will that be parabolic, this one or this one?
It would be the second one.
Second one. Okay. Why second one? Give me the reason behind that.
Because it's changing. Because
Okay.
velocity is
So
not constant.
change is happening in parabolic and this, both of them. Is that right? What
Right.
makes the difference between both of them? The parabolic graph and the straight line with constant slope graph.
Well, in the parabolic one, it gives you different values for like a negative or a positive.
No. Don't think. I just told what I told you right now. In parabolic graph, the double differentiation of the y value is constant.
Mhm.
Double differentiation. Do you know about double differentiation?
Yeah,
No? Okay, you
I
know?
do.
Okay. So angular values, angular position, right? And yeah, so if you say that, and for the straight line with constant slope, the slope is constant. Is that right? So what is the
Mhm.
slope of angular position versus time graph? If there is any angular position versus time graph, then what will be the slope of this graph? Give you
Velocity,
velocity.
angular
So if
velocity.
you draw a straight line, that means this slope, that means this slope is constant. This line means this slope is constant. Is that right?
Right.
So what is the slope of this graph? That will be velocity. Is the angular velocity constant?
Y-
No,
no,
don't go with here. They have written the wrong answers. What we have done? Was the angular velocity constant?
no,
No. So should you choose this one?
no. So then it has to be
So if this is not true, then this is true. Is that would you think like this? No. Yeah, you will think it like this. So yeah. Why this is true? The reason is that this graph means that the double differentiation. So that means rate of this if there is a parabolic graph. I don't know the parabola will go up or do move down. There are these two parabolas, right? Okay, we'll go that on that. But what I'm saying is that okay, what I'm saying is that angular position versus time, right? So parabolic means the rate of change of slope is constant. Okay, so slope is what? Slope of angular position versus time. What is the slope of this graph? Is that angular velocity?
yeah,
Angular velocity. Now parabolic graph means rate of change of slope. That means what? Slope is angular velocity. So rate of change of slope means rate of change of angular velocity with respect to time. With respect to time is constant. That means what? Rate of change of angular velocity with respect to time is what? Is that alpha?
yeah.
So alpha is constant. Are you getting that? So is
Yeah.
alpha constant? Is alpha constant in this case?
Yes.
Yes. So we will use parabolic curve. So the parabolic can be upward opening parabola and a downward opening parabola. Downward opening parabola means acceleration is negative, and upward opening parabola means acceleration is positive. I think in this case, the acceleration is positive, right? Is
Yes.
that right? So we'll use a upward opening parabola. Are you getting that?
Yeah.
So yeah. So you got to so this concept of graphs, these three graphs, this concept, the rate of change of slope. The slope is changing at a constant rate. In this one, the slope is constant. In this one, the y value is constant. This is a very important concept. It can be also used in kinematics question. Okay. If you didn't understand, then please ask again.
Hmm.
You got it, or you want to ask again? Please be
No,
frank.
I think yeah.
You got it? Okay.
Yeah.
Okay, so we are done with this one.
All right.
Now, do you have any do you have any questions from the college board?
No, I think I'm okay.
You're okay?
Yeah, I think that was really helpful. Thank you so much.
Okay, welcome. Okay, bye-bye. Take care.
Yep.
Good luck for your exams.
Thank you.
Yeah, bye.
Thank you.